ꯉꯁꯤꯒꯤ ꯚꯤꯗꯤꯑꯣꯁꯤꯗ ꯑꯩ decarboxylation ꯀꯣ ꯀ꯭ꯂꯥꯁ 11ꯒꯤ ꯍꯥꯏꯗ꯭ꯔꯣꯀꯥꯔꯕꯟꯁꯀꯤ ꯑꯗꯨꯒ 12ꯀꯤꯅ aldehydes ketones and carboxylic acid ꯍꯥꯏꯕ ꯆꯦꯞꯇꯔꯗꯨꯒꯤ ꯀꯣ carboxylic acid ꯄꯥꯔꯠꯇ decarboxylation ꯍꯥꯏꯅ ꯇꯣꯄꯤꯛ ꯑꯃ ꯌꯥꯎꯏ ꯑꯗꯨꯒꯤ ꯃꯇꯥꯡꯗ ꯑꯩ ꯃꯥꯒꯤ ꯃꯦꯀꯥꯅꯤꯖꯝ ꯀꯣ decarboxylation ꯍꯥꯏꯅ ꯍꯥꯏꯕ ꯀꯣ decarboxylation ꯁꯤꯗ ꯀꯅꯥꯒꯤ ꯅꯣ ꯍꯥꯏꯀꯥꯟꯗꯅꯦ of decarboxylation actually ani thokna khaido ai decarboxylation of sumaina dum irage ko RCOONA haidana ko this is the decarboxylation of sodium carboxylate. Now decarboxylation of sodium carboxylate is of two types. One is heating with soda lime. Okay, soda lime si karino haiba matamda ko sodium hydroxide sini calcium oxide ki mixture ko sidaida reaction ji kamen laki hai kanda okay say R C double bond O Na, this is sodium carboxylate. When this sodium carboxylate is heated with sodium hydroxide in presence of calcium oxide, then we get this alkyl group attached to this hydrogen actually. So as a trick I can say like this is just a trick up to here. Okay, so this will go out and this whole atoms will form sodium carbonate as the byproduct. This is sodium carbonate and this hydrogen will be attached to this alkyl group, so this will be our alkane. Okay, these two will be formed and this is our alkane. Now this is our alkane. Okay, let me give the mechanism of this reaction along with some examples in this video. Okay, let me write mechanism here. Mechanism is very simple. Let me change the color. Okay, mechanism. Okay, this is the mechanism of this reaction. So this is sodium carboxylate ion. This is the carboxylate ion. So this will be formed when carboxylic acid is reacted with sodium hydroxide, acid base type reaction, and I'm not writing sodium here. Now what will happen is this minus will form this. There are 2 electrons here along with these 4 electrons. These 2 electrons will form a pi bond between carbon and oxygen, and this bond is broken. This bond is broken like this, so we get a carb anion as the intermediate in this reaction, and this will be carbon dioxide, CO2. This carbon dioxide will form, and this carb anion will abstract a hydrogen from water like this. This will be from water because we are taking aqueous solution here. So this carb anion, which is a very strong base, this will be from water, right? And product will be this our alkane. This is the mechanism, very simple mechanism. Okay, but what we need to know is this is our intermediate. Carb anion is the intermediate here. This is the intermediate, right? So let me write some examples here of this reaction. first example is CH3 COONA, and if it is heated with sodium hydroxide and calcium oxide plus heat, then what will happen? This whole thing will go out as sodium carbonate, right? And hydrogen is attached here, so we get methane. I'm not writing the byproduct here. So the carb anion or the intermediate in this reaction will be CH3 minus ion. So if I give another example, this will be our sodium propanoate, and if it is heated with this mixture, then ethane will be formed. Now the important point here is the rate of this reaction to form methane from sodium acetate, and the rate of reaction to form ethane from sodium propanoate. If these two rates are represented by R1 and R2, the rate of this reaction is suppose R1 and the rate of this reaction is supposed to be R2, then which R will be greater, which reactivity between A and B will be more? That will be dependent upon the stability of the carbon ion, right? So if I give another example, and let me compare the rates of the three reactions. This is the third example. If I give this as the example, ClCH2 COONA, and if it is heated with the mixture, then what we will get is chloromethane. This will be the product here. Now if the rate of this reaction is suppose R3, so compare this R1, R2 and R3, which will be more. So this question will be dependent upon the stability of the carb anion. More is the stability of the carb anion formed in this reaction, more the reactivity or rate will be. So in this case the carb anion will be methyl carbanion, and in this case the carbanion will be ethyl carbanion, and in this case chloromethyl carbanion will be formed. So as we know that an electron donating group, this methyl will be an electron donating group to this CH2 minus ion. This will decrease the stability of this anion, but Cl is an electron withdrawing group, so this will increase the stability of this carb anion. So this will be most stable carb anion formed. So the rate of this reaction will be more. Okay, so the reactivity order, this implies the reactivity order will be R3 will be most reactive, then what? R1 will come in the second place, R1, because stability of methyl carbanion and the ethyl carbanion, between these two carbanions methyl carbanion will be more stable, so R1 will come before R2. So this will be the rate of the, this will be the order of the reactivities or order of the rates. Okay, now this is the first reaction mechanism of decarboxylation, in which sodium carboxylate is heated with soda lime to form alkanes containing one carbon atom less than the carbon atom present in the carboxylate ion. Okay, so in the next video I'll explain the mechanism of another decarboxylation reaction, which is called Kolb's electrolysis, in which also alkane is formed as the product, but the reaction is different. So for today, let me complete this video. Please share this video to your friends who are preparing for NEET and IIT. And if you are new to the channel, please subscribe this channel, and also press the notification button so that whenever I upload a video you get it immediately. Thank you all.